If you've been tracking the agent space, you've seen the pivot. We're moving past chatbots that just talk into systems that actually interact with your environment. But most of these agents are still tethered to the cloud or built for desktops. They miss the most important context, your phone. Today, we're breaking down X-OmniClaw, a new edge-native mobile agent from OPPO that treats the smartphone not just as a display, but as a unified computational interface. It's built on 3 co-design pillars: perception, memory, and action. And unlike cloud-hosted remote control solutions, it runs locally, respects your data boundaries, and actually handles the messy reality of modern mobile interfaces. Let's walk through the architecture. The first thing to understand is the deployment model. Most mobile agent frameworks run virtualized Android instances in data centers. That works for benchmarking, but it cuts the agent off from your real sensors, local files, and actual app states. X-OmniClaw flips that paradigm. It's edge-native, meaning the core perception and execution logic lives directly on your device. Think of your phone as the vehicle, the agent as the internal control engine, and the cloud LLM as just the high-level reasoning fuel. This architecture converges into 3 tightly coupled modules: omni-perception, omni-memory, and omni-action. They aren't bolted on as separate tools. They're designed to run in a single, continuous execution loop. Let's start with omni-perception. Mobile environments are inherently noisy. You're scrolling, listening to media, maybe recording voice notes, all while the screen updates. X-OmniClaw handles this by funneling every input: screen captures, camera feeds, microphone audio, even scheduled system triggers, into a unified ingress pipeline. Crucially, it doesn't just dump raw streams into a model. It uses a temporal alignment module to sync audio and visual data using shared timestamps. For audio, it runs on-device adaptive acoustic echo cancellation, so your own speaker output doesn't corrupt the speech recognition. Once the signals are cleaned and aligned, a vision language model steps in for scene-grounded intent understanding. Instead of blindly executing commands, the VLM interprets the visual context alongside your query. If you point your camera at a product and ask, "How much is this?" the system first identifies the object, infers the shopping intent, and only then launches the appropriate app with a structured search query. It's a deliberate, context-aware step before any action is taken. Perception is only half the equation. Without memory, an agent is just a stateless automation script. That's where omni-memory comes in. The system maintains 2 distinct layers: working memory and long-term personal memory. Working memory is your runtime context. It tracks screenshots, compressed semantic observations, and execution state across app switches and task interruptions. This is what lets the agent resume a multi-step workflow without losing its place. But long-term memory is where the architecture gets interesting. X-OmniClaw continuously distills data from your local environment: photos, interaction logs, metadata, into persistent, structured memory artifacts. Instead of storing raw images, it generates compact semantic records capturing objects, scenes, and user cues. These are stored locally and can be queried later. To keep this pipeline stable and secure, the system uses a skill and tool coordination model. Separate skills handle memory maintenance, like incremental scanning and summarization, while other skills handle consumption, like semantic retrieval or memory-grounded operations. Before anything is written to long-term storage, it passes through a unified filtering and redaction layer to strip sensitive data. Users also have explicit controls to toggle what gets indexed and what gets injected into the agent's context. Finally, we have omni-action. This is where most mobile agents hit a wall. Android apps are wildly inconsistent. Some expose clean accessibility trees, others rely on custom rendering, and some bury critical buttons under ad overlays. X-OmniClaw solves this with hybrid UI understanding. It doesn't rely on a single signal. It combines structural XML metadata, on-device visual grounding models, and OCR. When the accessibility tree is reliable, it uses it for precision. When it's missing, ambiguous, or cluttered, visual grounding and text recognition step in to locate the exact click target. But it goes further with trajectory cloning and replay. Instead of forcing the agent to click through every screen step by step, X-OmniClaw records successful navigation paths and distills them into reusable skill cards. It does this by introspecting the Android activity stack using dumpsies. It extracts deep links, intent parameters, and action URIs, then maps them to a structured bookmark. When you later trigger that skill, the system bypasses the UI navigation entirely and jumps straight to the target state using a multi-tier launch strategy. If the deep link fails because an activity isn't exported, it falls back to incremental keyword filtering, then full dumpsies parsing, and finally task stack restoration to bring the app back to its previous state. This makes execution dramatically faster and far more robust against UI drift or unexpected pop-ups. These architectural choices translate directly into real-world workflows. In one scenario, the agent acts as a camera-informed co-pilot. You point your phone at a product, ask a question, and it handles the entire shopping loop. Identifies the item, launches the app, scrolls through results, extracts prices and ratings using VLM-based reading, and summarizes the findings. In another, it operates as a screen avatar, a lightweight floating companion that watches your active screen and executes long-chain tasks autonomously, like solving a series of problems or navigating a complex settings menu. And for power users, The proactive memory system can automatically index your photo gallery during idle time. You just say, make a highlight reel of the parrot photos, and the agent retrieves the semantic memory, batches the files, and uses a deep link to jump straight into CapCut's one-tap composition interface. No manual browsing, no step-by-step clicking. X-OmniClaw represents a clear shift in how we should think about mobile AI. It's not about remote controlling a cloud phone or blindly automating screenshots. It's about treating the device as a first-person computational interface that continuously integrates context, preserves personal history, and executes with precision. Looking ahead, the team is focusing on 3 key areas: self-evolving execution trajectories that compress complex reasoning chains to save tokens, dynamic memory evolution with semantic consolidation and selective forgetting, and a tighter device-cloud synergy that keeps daily tasks local while offloading heavy open-domain reasoning securely. The full architecture, code, and research materials are being released as open source, which is exactly how this field should move forward. If you're building agents, working on mobile automation, or just trying to understand where the next generation of AI interfaces is heading, I highly recommend digging into the paper and the repository. The link is in the description. Let me know in the comments how you think edge-native memory and hybrid UI grounding will impact the agent ecosystem. Thanks for watching, and I'll see you in the next one.